Hey guys, welcome. Yeah, so I said that if I found a couple of interesting, challenging trigonometric equations to solve, then I'd make a bonus set for our video series on solving trigonometric equations. I didn't just find two, I found three really cool problems. So I'm going to dedicate a video to each. Here's example 9. May the Lord Jesus Christ bless this video, bless you and I. Let's get started. So the question that we have to solve here is this, which is, let me write it in black. It's solve cosine of 3 theta is equal to 0. Is equal to 0 on the interval negative pi over 2, comma pi over 2. So inclusive of negative pi over 2 and pi over 2. All right, now to solve this, let's start with a complex number. R is equal to cos theta plus I times sine theta. So R is cis theta, and obviously once theta is specified, this is a complex number, right? Now, what is R cubed? Yes, this doesn't look like it has anything to do with solving that, but it has everything to do with solving that. So just be patient. So R cubed would be that, right? All right. Okay, now we know from binomial expansion, and I have binomial expansion through Pascal's triangle, a couple of videos so far, and I'll make more, and many videos on the binomial expansion formula or the binomial theorem, including its proof, so check that out. Now we know from binomial expansion that a plus b to the third power is equal to a cubed plus 3a squared b plus 3ab squared plus b cubed, right? And so we could let a be cos theta, it's kind of small, and then b be I times sine theta, and we have a plus b cubed here. So using this, we can see that r cubed here is equal to cos cubed plus 3 cos squared theta times I sine theta, right? See, this is why I don't love color coding, but it's all right. It's all right. We'll live, or I'll live. 3 and then cos theta. I'm just using this, right? And then times I sine theta squared. All right. And then finally plus I sine theta cubed, right? Okay, I sine theta cubed. Okay, and we can simplify this a little bit. We can clean it up. So r cubed is going to be, well, it's going to be cosine cubed theta. And notice that in this part, I'm going to get I squared sine squared. I squared is -1. So this term will not have an I in it. It'll just be negative 3 cos theta times sine squared theta. So I'll group that with this, which doesn't have an I in it. So I'm going to write minus 3 cos theta and then sine squared theta. But the remaining two terms, this guy and this guy, will have an I in them. This guy, obviously, and this guy, because I cubed sine cubed is what we're going to get. And I cubed is negative I, so I'm going to get negative I times sine cubed in this part. So if we put together the two terms that have an I in them, we could write them as plus parenthesis 3 cos squared. This cos squared is poor. 3 cos squared theta sine theta, and this we said is going to be minus I times sine cubed, so minus sine cubed theta, and all of this times I, right? Okay, cool. All right. But we said that R is equal to cis theta, right? So R, let me write it in black actually. R is equal to cis theta, right? Where cis theta is an abbreviation for cosine theta plus I times sine theta. I have videos on Moivre's theorem, so feel free to watch those videos. But if this is r, then r cubed, right, is equal to cis 3 theta, because according to Moivre's theorem, if r is cis theta, then r to the n is cis n theta. That's to say that r cubed is equal to cosine 3 theta plus I times sine 3 theta. And r is the same here and before we cubed it here, right? And therefore, if we write this complex number here in standard form, we can say that this is x plus I times y, where this is y. Well, this too, this version of r cubed is x plus, I guess I could put the I in front here, right, if I so chose, I times y, where this is y. So then, since this r cubed is the same as this r cubed, the comparison would lead us to conclude that cosine 3 theta, right here, cosine 3 theta must equal this here. So that's what we're going to use to move forward. We're going to replace cosine 3 theta is equal to 0 with this is equal to 0 and proceed to solving. Yeah? Okay, cool. So let's do that. So I rewrite this original equation in this form and write cos cubed theta minus 3 cos theta, and then it's times sine squared theta, right? Times sine squared theta is equal to 0, right? Is equal to 0. All right, cool. We probably need the space over here. Maybe not, but most likely. So let me get rid of this. And all right, coming back here. Remember, we said that when you solve trig equations, sometimes you'll have a mixed bag of sines and cosines and you can't do anything about it. But whenever you can do something about it, do something about it. So here, cosine is dominant, so we want to make this equation all about cosine. To do that, I could do this, cos cubed theta minus 3 cos theta. And in place of sine squared theta, I could write 1 minus cosine squared theta, right? Equals 0. Okay, so this turns into cos cubed theta minus, I distribute this minus 3 cos theta to here and to there, so I get minus 3 cos theta, and then plus 3 cos cubed theta is equal to 0. Got it. Now 3 cos cubed and cos cubed combine to 4 cos cubed theta minus 3 cos theta is equal to 0, right? Okay, and from here I could factor out a cos theta, and when I do, I get cos theta times 4 cos squared theta minus 3 is equal to 0. And this here will be true if cos theta is equal to 0, or if 4 cos squared theta minus 3 is equal to 0, right? Now for cos theta is equal to 0, you could just draw the graph of cosine. Right? Like from negative pi over 2 to pi over 2. And cosine is symmetric about the y. So it's going to look like this, right? Where it strikes 0 here and here. And those two places are negative pi over 2 and pi over 2. So from this, we get two solutions, which is theta is equal to negative pi over 2 and pi over 2. And then for this equation, first we see that 4 cosine squared theta minus 3 is equal to 0 implies that cosine theta is equal to plus or minus, it's equal to plus or minus the square root of 3 over 2, right? And then we draw the quadrants. I've showed you how to do this many a time. So draw the quadrants, and where do we need reference triangles? Wherever cosine is positive because of the plus root 3 over 2. And so that's here and here. And where it's negative, which is because of the minus root 3 over 2. And cosine is negative here and here. But notice, looking at our restriction, we need to look from negative pi over 2, which is here, to pi over 2, which is here. So we ignore the places where cosine is negative. So really we need to only worry about this, right? Because of the interval that we're given. So we just draw two reference triangles, one here, and then another one here. And then make cosine root 3 over 2, meaning we have a root 3 here, and a 2 here, and a 2 here. And so that means that this angle here is 30, and this angle here is 30, right? And so one of them going clockwise for negative angles is going to be that, which is negative pi over 6. Since we're given answers or intervals in radians, our answers have to also be in radians. And the other for the positive is go counterclockwise, and that's 30 or pi over 6. So from this equation, our two solutions are theta is equal to negative pi over 6 and then pi over 6. Yeah? That's all of them. All right, I had fun solving this problem, and I hope you enjoyed watching this problem. Follow Jesus, or at least Allah. All right, keep watching. Take care.